Continuing the problems in the stiffness method. So we have a beam with the fixed and support A. We have a B with hinge roller, C with a roller, and for AB we have a UDL where W is equal to 4P by L. The first section, first beam is 2EI, is a pressure rigidity. For the beam BC it is EI. Then the P load acting at L by 3 from the left, and also one more P L by 3 from the right. This is X direction, Y direction, and the Z direction. So the kinematic indeterminacy is the unknown displacement or two displacement. One is the rotation at the B, rotation at the C. The member stiffness matrix of a beam member SMI is equal to 2EI by L into 2112. You can refer the previous videos for the explanation of SMI. And the unassembled stiffness matrix SMI is equal to 2EI by L into this one will be for the beam AB, and this is for the beam BC. And now we are making the beam as fixed ended, as there is no joint load. We will convert this UDL to this joint load as well as P to the equivalent joint loads, as we are making fixed beam with the UDL. With the UDL, we have W L square by 8 as the moment, and W total load by 2 as a reaction for this one. And for P, we have the equation which I have discussed earlier for the eccentric, like with the A and B for the P, and for this one also has to be separately analyzed and then has to be added. Will give you PL by 3 as a moment and 2P as a reaction force, because the total load is 4P by L into L will give you the cancellation, and then 4P is the total load by 2 will be 2P reaction, and for here total P plus P is the total load 2P P on both supports, and the moments are WL squared by 12 for here, and the corresponding equations are refer, because for the center it is WL by 8. For the P you have to find it WA square B by L square and W AB square by L square. Yeah. So the equivalent joint load will be just the reverse of the fixed end action. That is, the fixed end action was upward reaction, it was made to downward 2P. All the this is actually added 2P plus P will be 3P, and then P at the right side. Then all the moments are actually taken as negative of the fixed end reactions. We have 3 redundants. So the joint displacements, we have a fixed end left, then one more rod at B and rod at C. So the free unknown joint displacements are the dj, and the restrained displacements are dr. So the dr1 is equal to 0, being a fixed end, the vertical movement is restrained. dr2 is 0 because being fixed and rotation is restrained. dr3 equal to 0 because due to the hinge or roller. dr4 is equal to 0, there is no vertical movement, and the free movement will be allowed in dj1 and dj2, where the rotation is allowed like this. The rotation is allowed with respect to the B. Then each column in the submatrix of CMJ consists of member displacement caused by the unit value of unknown displacement applied to the restraint structure, and CMR consists of the member displacement due to the unit value of support displacement applied to the restraint structure. So the J stands for the member displacement the value of unknown displacement, and the R is the like the restrained deflection or displacement. It is the unit value of support displacement to the restraint structure. So upon the action, so we have only one joint for getting the first matrix. The dj1 is permitted, so that the dj2 is restrained. So dj1 is equal to 1. Okay, so we are applying unit rotation at here, so that the rotation will be 1 for this joint, and at here being a fixed end, the rotation will be 0. And while applying dj2 is equal to 1, here there will be a rotation, here 0, here 0, and here 0. So all those things are noted as CMJ due to the, it is a displacement, it is a member displacement caused by the unit value of unknown displacement applied to the restraint structure. Similarly, we can apply for the support displacement also. So we have basically 4 restrained dr1, dr2, dr4, and dr3. So 3 other, and the first one will be dr1 will be support settlement, dr2 will be support rotation, dr3 will be support settlement, dr4 will be support settlement. Applying the dr1 alone with no rotation here at this point, but with respect to the center there is a net value of 1 by L and 1 by L for this one, and being the both then fixed, the displacement or rotation is not transferred to the BC. That's why 0 and 0 here. And for dr2 there is no vertical displacement, only rotation is allowed, so this rotation is there, but being in the other end fixed, there is no rotation at here at B left, and also it is not transferred to the BC beam. And for the dr3 is equal to 1, for this one there will be an equal transfer with respect to the center. There will be a rotation which is minus 1 by L, minus 1 by L, 1 by L, and 1 by L, which we had discussed in the previous slides. And for the rightmost one also, there will be it will be the same as for the dr1, same thing for dr4, but only thing is the sign change, being anti-clockwise positive. Hence the full CMR is written. CMR is written in the column wise. Then CM structure is equal to CMJ into CMR upon the CMS is equal to CMJ into CMR. So we are writing all the matrices in a clubbed way. Then we have the equations. The joint displacement is given by dj is equal to sjj inverse into aj minus sjr into dr. Here also the dr will be null matrix as no support displacements are announced or it is given in the question. We will see a problem later where there is a dr value. Okay, so this term will get 0. So dj is equal to sjj inverse into aj. So Sjj, we know the equation, and we can get the Sjj value. Similarly, the free unknown joint displacement dj is equal to Sjj inverse into Aj. Upon solution, we will get the value as PL square by 18 EA into 0 and 1, the unknown displacements. Okay. Then we have the support reactions equation given by AR is equal to minus ARC plus SRJ into DJ plus SRR into DR. The DR is a null matrix, so this term will get cancelled, and AR is equal to minus ARC plus SRJ into DJ. SRJ is given by CMR transpose into SM into CMJ. You know the values of CMR and CMJ. So applying it in the equation, we get the SRJ. Then AR is equal to minus ARC plus SRJ and DJ. Applying in the equation, and we'll get the value of AR 2P PL by 3, 10P by 3, and 2P by 3. Which are the support reaction. There is a one will be the moment reaction, and then the two reactions. Okay, our first one was the reaction, second one was the moment. So this will be the corresponding moment. This will be the moment, and this will be the reaction, this will be the reaction, this will be the reaction. The member end actions are given by AM final is equal to AMF plus SM into CMJ DJ plus CMR DR. Here also DR is 0, so this term will get neglected. DR is null matrix, so AM final is equal to AMF plus SM into CMJ into DJ. So AM final is equal to PL by 9 into 3 minus 3, 2 minus 2, which is the AMF value which you have found previously. Okay, plus 2 EA by L into the SM matrix into a CMJ matrix into the DJ matrix, which we have found in the previous slide. This one. The AM final is equal to, then again simplifying, we'll get the value as PL by 3 into 1 minus 1, 1 and 0. Alternatively, the stiffness matrix of the structure is equal to CMS transpose into SM into CMS. Through the equation, we will get again solve this big matrix and get the value of the stiffness matrix of the structure, which include the stiffness matrix of the joints as well as the bundles. Next question is a continuous beam with support A, B and C as hinge, and the AB is solved with 10 kN per meter, 4 meter length, BC by 40 kN, by 4 meter length is actually at the central position, and the CD overhang 2 meter length with a 100 kN at the end. So the unknown values under kinematic indeterminacy is 3. All are the rotations at the various point at A, at B, and at C. Considering the joint D in the overhang portion, because there is no reaction there, we are not concerned about that. So the joint displacements are dj1, dj2, and dj3. The member stiffness matrix of the beam member is given by SMI is equal to 2A by L into 2, 1, 1, 2. And the unassembled stiffness matrix SMI is equal to 2A by L into. So this one will correspond to the first of the beam portion, and this is the second portion. Then again we are converting this UDL to the equivalent joint load, and also this force to the equivalent joint load. So first one will be WL square by 12, which will be 13.33, 30.33, and the reaction will be total load by 2. And for the right support it will be WL by 8, and the reaction will be the W by 2. Those are the fixed end action, and the equivalent joint load will be the this reverse of the fixed end action, then plus the actual joint load will give you the combined joint load, which is shown as in the second figure. Then to get the matrix, displacement matrix for dj1 is equal to 1, we are applying a unit rotation here, then all the other value will be 0, 0, 0, which is shown here. For dj2 is equal to 1, we are applying a rotation here, so the rotation will be here also, so it will be 1, 1, and all other will be 0, 0. Similarly for dj3 is equal to 1, only here there will be a rotation, all other will be 0. So the CMJ matrix is written accordingly. The joint displacements are dj is equal to sjj inverse into aj. Here also the dr is a null matrix. So sjj into cmj transpose into cmj is equal to, you can actually substitute the equations to get the final value of sjj. The joint displacement dj is equal to sjj inverse into aj. So we obtain the value as 1 by EA into minus 43 by 435, 60.33 minus 210, which is shown in the figure. So being this negative, that should be a clockwise rotation. Then the member and actions AM final is equal to AMF plus SM into CMJ into DJ is equal to 13.33 minus 13.33, 20, 20. They are the equivalent joint loads, combined joint loads. Plus SM into CMJ into DJ will give you the values of final moments, final reaction 0, 20, 25, minus 25, and minus 200. So it is written here AM final, member and moments, and then the BMD is drawn from the member and moments. Here being 0, there is 0, and this gradually increasing to 25 at the B point. Then again at the right end of the beam it is also 25. Then it changes to 200 at the C point. Yes, this is the problem on settlement. The Problem number 5 is to analyze the beam. Suppose B has a downward settlement of 30 mm. A is equal to 5.6 into 10 power 3 kilometer meter square. So we have the beam A, B, C, D. There are three rotations possible, one at B, C, and D, and it is kinematically indeterminate to third degree rotations to 3. The member stiffness matrix of the beam member is given by SMI is equal to 2A by L into 2, 1, 1, 2. The unassembled stiffness matrix will be a 6 by 6 matrix as we have three members 1, 2, and 3. And the first 2 will be corresponding to the first beam, this will be correspond to second beam, and this will be for the third beam. And the free unknown joint displacements dj, it happens at the point B, C, and D, and support settlement is also given for the P, which is 30 mm. This is a restrained displacement. For the first time we are dealing with dr. So we are finding the fixed moments, especially for the CD, and WL square by 12 will be the moments for the UDL 25, and hence the equivalent joint load will be the reverse of that one, which will be same as the combined joint load also, because there is no additional force. It will be the equivalent joint load. The CMJ and CMR consist of member displacement due to unit displacements on the restraint structure. So to find the CMJ, you have three conditions: DJ1 is equal to 1, DJ DJ1, DJ2, DJ3, and RDR1. So for DJ equal to 1, we are applying a rotation here. So here only the rotation will be there, 1, 1, or other will be 0. For the second case, applying here, here it will be 1 and 1, or other will be 0. For here, only 1 will be here, or others will be 0, which is not as here. And dr1 is equal to 1 by 4 because the length is actually 3 meter. For the beam AB, the length is 3 meter, and right side also 3 meter, middle span will be 6 meter. So 1 by L will be 1 by 3, minus 1 by 3, minus 1 by 3. For here the length is 6 meter, so 1 by 6, 1 by 6. Here there is no transfer, 0, 0. Is written here. The joint displacements dj is equal to sjj inverse into aj minus sjr dr. So here the dr is not 0, and we have to account that one. Sjj is equal to cmj transpose into sm into cmj, which will be a longer equation to get the value EA by 3 into 610, 162, and 024. Sjr is equal to similar equation CMJ transpose into SM into CM bar. So this is actually introduced for the first time due to the presence of support settlement. So the value will be EA by 3 into 3 minus 3 by 2, 1 by 2, 0. Hence DJ is the joint displacement applying to all these values. DJ is equal to SJJ inverse into AJ minus SJR into DR, and getting through a long equation the value minus 0.007583, 0.005, and 0.0031 as the joint displacement. This stop here. Here already there is support settlement of 30, and this rotation is actually found from the previous slide. And then the other joint rotations. The support reactions also have a long equation. AR is equal to minus ARC plus SRJ into DJ plus SRR into DR. So the SRJ is known to you. CMR transpose into SM into CMJ will give you minus like EA by 3 into minus 3 by 2 half 0. Simplifying the equation. SRR is equal to CMR transpose into SM into CMR. Will give you the value as EA by 2. Then we have AR is equal to minus ARC plus SRJ. So those things are applied in the equation to get the value of AR, which is equal to minus 62.35, which is the support reaction corresponding to the DR. That is the reaction at the B. Then the member end actions are given by AM finally is equal to AMF plus SM into CMJ DJ plus CMR DR. The AM finally is equal to the AMF value plus 2EA by 6 into the matrices corresponding to these values. Will give you the value 83.7, 55.4, minus 55.4, minus 40.3, 40.30. This will be the bending moment diagram based on the previous results. The 83.7, 55.4, 40.3 are drawn in the bending moment diagram. It's an alternative method for finding the SS is equal to CMS transpose into SM into CMS. So we know the value of CMS, SM and CMS. Then applying in the equation, we'll get the matrix, and in this matrix, it is actually a subcomponent of SJJ, SJR, SRJ, and SRR. Ordinarily, if all the possible settlements are accounted of, then CMS is equal to CMJ into CMR. This is the additional term coming. So we are writing CMJ CMR together as a big matrix, and then SS is equal to same equation CMS transpose into SM into CMS, and applying that, we will applying and simplifying the equation, we will get the matrix SJJ, SJR, SRJ, SRR. And the joint displacement dj is equal to sjj inverse into aj minus sjr into dr is equal to EA by 3 into this value will be sjj, then inverse into aj will be this value minus sjr into dr, support settlement of 30 mm. Then we'll give you the value of joint displacement as this. And also the support reactions AR is equal to minus ARC plus SRJ into DJ plus SRR into DR. AR is equal to ARC plus SRJ into DJ here plus SRR into DR will give you the value of AR is equal to 46.294, 83.627, minus 62.4347, 79.31, 36.56. And the member and actions are given by AM find is equal to AMF plus SM into CMJ DJ plus CMR DR. substitution, we get the value of AM500 as 83.7, 55.4 minus 55.4 minus 40.33, 40.3 and 0.